Hello everyone, thank you so much for joining again. So this is our last session on this webinar series. So on the past week we saw how to do 4D, 5D simulation, wind simulation, sun simulation, and last week was the light simulation, artificial light basically. And then this week is going to be rain flow simulation, and we are going to see wind-driven rain simulation using the model from Archicad, and we are going to use a tool called Simflow. Okay, so you can see here we are going to see wind-driven rain simulation, and for that we are using Simflow as I told earlier. So we are going to do two different simulations. So the first is wind simulation. We need to basically set the wind data on the around the building, and then we are going to perform the rain simulation over the wind simulation results. So it's a two simulation, and we are going to combine that two, and then based on the first one, we are going to do the rain simulation after that. And then we will also do see water flow simulation. Basically, once after the wind falls on the building, the water will flow, right? So that simulation is water flow simulation. But during the first simulation, we are not going to show the water flow because if we do the water flow simulation, once after the droplets or the rain hits the building, it will consume a huge resources from the computer, and also to perform such simulation, it will take even weeks, even for a smaller building. Okay, so in order to simplify that, we are just going to do a wind-driven simulation on seeing how or where exactly the droplets fall on the building based on the wind around the building. Okay, so once after it hits the building, the simulation stops there. It's not going to flow anywhere else. But for that, I'm going to show a water flow simulation separately, which is a simpler simulation as well. So once there is a water droplet on the surface, based on the surface, it will just flow around, and then we will show the flow lines of that water flow simulation as well. Okay. All right, let's get started. So as I told, wind simulation is done using the Simflow tool. Let me show the model first. So I've created a very simple model here in Archicad, something like this. Okay, so just for the sake of simplicity, I've created a very simple model. So as I have been telling throughout this series, try to have a simple model for a simulation. So you should not have too many polygons in your model. So if you have too many polygons, then it will create a huge polygons, and then it will have too much big mesh data when you're performing the simulation. Okay, so what you are going to do is we are going to save this particular model in STL file format. Okay, so the STL file format can be imported inside the SimFlow, and then we'll be able to perform the simulation there, wind-driven rain simulation. Okay, so go to file. Once after you have created the model, go to the file, and then we can go to save as, and then choose the stereo lithography file, which is the STL file format, and then you can save it on your machine, save the file on your machine. Okay, especially when you have a very big model, we can try to save the STL files room by room, but try to include all the external factors, like if there is a nearby building, or if there is something else just near to the room, you can consider that also inside this STL file while saving. So just include the nearby surrounding of the room in the STL file while you are saving, so that you can create a most closer replica of your real life conditions. Okay. So once you save that as an STL file using the save as option, you can go to the Simflow, and then you can perform the simulation there. Okay. So let me show a few options here before we go into the simulation in SimFlow. So here you can see I have a building, and then surrounding the building I have the faces, or the mesh around the building. So I basically have to create a mesh around the building, and then I need to set the boundary conditions for those meshes. Okay, so I'm going to have a box like this, and then I'm going to have, say for example, if the wind is from the north direction, so I just choose that particular direction in the boundary, and then I will set that as a inlet. Okay, and also if the rain also falls from the top, right? But if you have your the box that you're creating, which is much taller, then the rain that is entering the mesh from the top might not even reach the building. It will just go out throughout through this face. Okay, through the front face. If it is falling from top, before it reaches the building, it might fall out in this outlet. Okay, so in that case, you need not even consider the top surface as an inlet, but it's always good to have the top surface also as inlet. Okay, so the other surfaces are outlet. Basically, the wind takes away the rain from the other surfaces, but only the one that reaches the building will stick to the building. Okay, and inside is the building, so you can see that. Okay, all right. So let me go to the Simflow. So here is my Simflow. I'm just going to show the steps using which you can create this wind simulation. So as you can see here, I'm just doing the wind simulation first. For that, you just go to the geometry and then you can import your model from here. So you can add the model, you can choose the model from here. Once after you bring the model, you need to create the mesh as I told here. So you just have to create the mesh, and then here is the external mesh. So you can see here I've set the boundary conditions. Only two of them are inlet, rest all are outlet. Okay. And then this particular geometry for the external mesh, you need to select in such a way that it covers the entire building. Okay. Even if you are surrounding outside this building, you need to make sure the surroundings are within the mesh that you're creating, the base mesh. Okay. So after that, you can generate the mesh. So you can see here, here is my mesh. And then let me show you which is my inlet and which is my outlet. Okay. So here, if I go here, let me, okay. So I've just hidden the outlet so that you can see the inlet here. Okay. So the inlet is from the north side and also from the top. Okay. I've chosen these as inlet. And if I show the outlet, you can see so the rest of the faces are outlet. Okay, and I have my building also inside, which is the building that I just brought as an STL file here using the geometry. Okay, so once after I bring that, I need to generate the mesh. Once the mesh is generated, we can start the simulation. So for the wind simulation, first I'm using the steady state and incompressible flow and then the simple solver. Okay. So after you choose this, you should be able to select the turbulence here. So the turbulence model, you can choose from any one of these. So I'm choosing the RANS turbulence model. And then for the transportation, you can choose the air. So here we are using the air to flow through this building, right? So we choose the air. And then the next is the boundary conditions. Okay, so you can see here I have the model that I've imported, and then I have inlet and outlet. Okay, so using the inlet, I'm choosing the velocity inlet. Okay, so I can choose the velocity inlet, and then in the inlet you can see I'm giving average wind speed of 3.4 meters. You can choose anything. So if you have average data around your building, you can choose the value or the speed of the wind. Okay, and then the turbulence, you can just leave it to the default values. And then for the outlet, you can choose the outlet as the pressure, inlet, outlet velocity, and then the atmospheric pressure is also 0. Okay, so it's going to be basically atmospheric pressure. And then we have this pressure outlet inlet as the velocity. And then for the sample model, you can just leave it to the default values here. Don't change anything here. And then the next is initial conditions. Um, so if in case you want to measure the velocity of the wind and all that, you can choose here the U. So this will help you to measure the velocity of the wind. Okay, so if in case you don't want, just leave it to the default values, and then you can just run the simulation here. And the number of iterations I've given is the 1,000 number of iterations, and then we can simply run the simulation. So I've already run the simulation. I don't want to run it again. Maybe I will just show you the results. Okay, so you can see here this is the mesh that we have created. So let me show the sample mesh. Okay, so here is the sample mesh. or the building sample that we just brought inside. So the wind that is hitting, sorry. Okay, so the wind is hitting from this north direction and also from the top side as well. And you can see here the wind here, or the velocity of the wind here is higher. So here is the graph or the legend that we have. So the places where you can see the red color ones are having a higher wind velocity, and on the other side we have lesser wind velocity around the building. Okay, so if I just create a um, surface around this, you'll be able to see the wind speed clearly. Okay, so let me just move it to Y. Okay, so you can see here the wind enters through the window through this direction, and then it has a higher velocity inside, and it comes out through the other window, because I just kept an opening there. I did not really create a window there, but I just kept an opening there. Okay, and also from this side the wind is blowing at a higher speed, and then it hits the building on the top as well. Okay, so this is the result that we have obtained. So we are going to save this result, and then we are going to use the same wind, inside the building, and then or around the building, and then you are going to do a wind driven rain simulation. Okay, so for that what we need to do is we need to just save this file. So we just go here and then save this file. Once after you save the file, you'll be able to see, there is a link here which will open the model. Okay, so if you click that, it will open the simulation file, and you need to go into the latest simulation. The latest simulation for me is 323, and then you need to rename uh, these three files. Okay, so the epsilon, k, and u file. Okay, so you need to rename by adding a word bulk into it. Okay, so just add the word bulk to it, and then you can just open the new file, or you can open this same file and then save it with a different name. Okay, so you can save it with a different name here. Click Save As and save it with a different name. So I have saved it with a different name, which is a wind driven side rain simulation. And then you will have all the wind data added to this file. And then you're going to just perform a rain simulation around the building. Okay. So let me just go back here. So you need not change anything on the geometry mesh or hex mesh, because it is already coming from the previous wind simulation that we have performed. But we need to go and change the solver here. So here we are going to change it to a transient and incompressible flow, and then we are going to choose MPPIC. Okay, so we are choosing this particular solver, and then we need to set the injection where we are going to show the rain here. Okay, choose the boundary injector, and then for the injector, I'm going to choose, I need to enter the time duration of my simulation. So for this particular study, I've just done a 15 seconds simulation, and I need to calculate the mass of water that will flow through the mesh on this 15 seconds. Okay, so I will show the calculation for that in my slides. Okay, so here is the calculation. So for example, if it is a 35 rainfall in an area, you can see here I've converted this to a meter, and then it's going to be on 1 meter by 1 meter. Okay, so this is the volume of rain that falls in, if it is a 35 rainfall. Okay, and then it is going to be per hour. So I'm going to change it to per second. So I'm dividing it by 3,600, and then so you can see, let me just highlight. So this is the volume of rain per second. Okay, in meter cube. Okay, so I need to multiply the surface area of my mesh using through which the water enters. Okay, so these two are the inlet mesh area of my side and then the top. Okay, I'm multiplying it that, and then I'm multiplying it with 15 seconds, because it's going to be for 15 second simulation. And then this is currently in meter cube, right? So I'm converting it to kg. So 1 meter cube of water is 1000 kg. So I'm multiplying it by 1000, and then I'm getting this 15.67, which could be like 15 per second. Maybe 1 kg per second is approximate value. Okay. So going back to the Simflow, I have entered the values, and under the boundary, you need to select inlet, and I'm also choosing the direction or the speed of my wind. So the speed of the rain droplet. So the speed of the rain droplet approximately is 9 meter per second. So I'm choosing it here on the x direction, sorry, on the x direction, and also on the from the top. Since it is coming down from the top, so I've chosen -9 here. Okay, and then rest all you need not change anything. And the turbulence, I'm going to leave it the same as the previous simulation. And the transport properties is again the air. So the water droplet is passing through the air, so it's going to be air. And then under the solutions, you just change this collectors to 0 and 0. So we are just going to use the outer collector here, and then uncheck this value. And then the operating conditions is going to be the gravitational force. The gravitational force is -9.81. And then on the boundary conditions, so here you can see here on the boundary condition, the inlet is again is somewhere from where the rain comes. So it's going to be velocity inlet, and you will have a new tab here, particles, and you can choose escape here for inlet and outlet, and you select the sample model session here, and then you need to choose stick. Okay, so the whatever the droplet falls on the building, it will stick to the surface of the uh, building that we have created. Okay, and then under the initial conditions, so you need to go to the initial conditions here, and then you need to go to map. Okay, so just check this value here, and then go inside the map form, and then you need to select the wind simulation folder where you have selected the save the wind simulation. Okay, and then choose consistent mesh. I've already done that. Since I've run the simulation already, it is disabled for me now, but for you, you'll be able to select the wind simulation folder where you have saved the wind simulation. Okay, and then you come back here to the run, and then you'll be able to run the simulation. So you can see here I'm giving a simulation time of 15, but my rain will stop at 16, but my rain will stop at 15 seconds. Okay, because previously in the discrete phase, here you can choose, see I've given the duration of the rainfall is 15. Okay, so I'm giving an extra one once again for my simulation, and you can choose the time step and all that based on your level of detail that you want to see on your simulation results. And then you can simply click continue to run the simulation. So when you run the simulation, it might take like 2 to 3 minutes for this particular model, and you can see the turbulence of wind around the building and then the rain plotted here. And then on the post processing, I will show the results. Okay, so now I will skip the 0 time, and then I want to see only the building. I don't want to see the external mesh. So I just choose to see the building. All right, here is my building. Okay, now let me change this to particle. Okay, so here I have the active particle, and then I will change the color of the rain droplets. Okay, so I don't want it to be dark blue. I'll change this to somewhere around the gray color, and then click OK. I will enable this OSP array so that we'll be able to see the rain droplets much clearer. Okay. All right. So let me just play the simulation here. So you can see here the droplets are falling on the building, and then it gets stuck or it is sticking to the building. So if you want the droplet to fall and then it will flow, it will take longer time to run the simulation. And also you can see that the rain is not falling directly down, it's just taken away by the winds a bit aside, and then it falls on the building. Okay, so you can see the running time here. So I've given the time step as very little bit so that it runs a little slower. And also if I zoom in, you will be able to see the droplets that are really sticking onto the building. Okay, and you can see inside also there are some droplets, which means that the rain is flowing in through this window opening. Okay, so the sunshade that we have allowed or kept on this building is not enough to retain the rain from entering through the window. Okay. So after 16 seconds, it will stop the rain, and then you will see all the droplets around the building. Okay, and you can also see some of the droplets are which are coming from the top are going away, which is not hitting the building, but it is going outside through the outlet as well. So it might happen as well. Okay. This particular simulation that we are doing doesn't take that much time because it's just hitting the building and then the simulation stops there. We are not letting the droplet to flow around based on the slope of the building. So you can see here the simulation has stopped already. Okay, so all the droplets are just sticking to the building, and you can see here there is a shade. So since it is falling from this direction, there is this side is not wet actually. Okay, because we have the shade here. And if you see the building is a little bit distorted because it's not exactly the shape of the building that we have created. Why? Because this is actually not the building, this is the mesh that we have created or generated based on the building. So while we generate the mesh, we need to give a refinement number so that you will create a exact indication of your building as a mesh. Okay, so where we need to refine is under the hex mesh. So you select the sample that you have imported, and then you need to refine the number here. So if you give a higher refinement number, the building will be in the same shape as you want. Since for the sake of simplicity, I just made it 0. That's why the building on the result is little bit disordered. Um, so yeah, you can see that here. So it's not exactly the same as what we have modeled in Archicad. So if you choose the refinement number as a little higher, maybe like 4 or 5, it will take longer time to simulate, but you will get a perfect result. Okay. All right. So this particular tool, Simflow, is very user friendly. So we just have to input some of the input data like the rain flow, the rate at which the rain flows into the mesh, and then the boundary conditions and what is the pressure at the boundary conditions. So it's very simple, and we just run the simulation. It gives the perfect result. And then once you do the post processing, you can save them as a screenshot, or you can save them as a video file. You can use these options here. Okay, to save them in a different way, and also the visualization can be changed. Just now you can see that I changed the color of the droplets, right? So even if I want to make it a little bit blue or something, I can just change as well. Okay, so if I just change it, so you can see here it becomes a little bit blue, and then I can rerun the simulation. So you can choose whichever color you want, and then you can just run your simulation and save this file. Okay, all right, let me go back to the presentation. Right here is the QR code which you can scan and download the Simflow tool. It's not free, but you have the trial version. But if in case you want to subscribe or you want to buy the software, you can use the contact detail that I'm showing here, and then you can purchase the tool to do the simulations. So you can also do wind simulation within this, not just the rain. You can do the wind simulation. Just now I showed, but you can even do a detailed wind simulation as well, and also the wind events rain simulation. Just now what we did, it can be done very easily. Okay. So the next is water flow simulation. So for this, I'm going to use Rhino Grasshopper, and inside Rhino Grasshopper, I'm going to use a plugin called Anemone. Okay, so you can scan the QR code here to download the plugin. And what I'm going to do is I'm going to get the BIM model from Archicad. I'm going to get all the mesh data or on the mark of the building, marks the building, and then I'm going to perform the simulation within Rhino Grasshopper. I'm going to bring back the results along with the building, and then I'm going to document it inside the Archicad. So this water flow simulation, what basically does is once after the water flows inside or flows to the surface of your building, how exactly it goes down or it flows down through the surface of the building, you are going to see. Okay, so let me show the Archicad model first. So here you can see the flow lines already because I've run the simulation. So you're able to see the flow lines. But this is the model that I'm going to use. So let me show the Rhino Grasshopper. Even here you can see the flow lines because I've already run the simulation. So it takes a little longer to run simulation. So I've already done. You can see clearly the flow line. So wherever the rain falls, right? So you'll be able to see the flow of water around the surface using this simulation. It's a very simple simulation, just a water flow simulation, not really a rain flow simulation. Wherever the water hits, from there it will just flow around. Okay. So I'm choosing the geometry, which is the building geometry, and then the mesh data from Archicad, and then I'm just creating the topo surface inside the Rhino Grasshopper, which is the green color surface that you're seeing here. And then once you create, um, let me just show you the anemone plugin here. Here is all dividing the number of surfaces, and then I'm creating the droplet there. So this is just creating the droplets in the building, and here is where the simulation happens. Okay, basically I will show you the concept how the simulation runs. So you can see here if there is a surface something like this. Let me change it to a laser pen. So if there is a surface like this, and when the droplet falls on this particular point, the simulation will try to go a little bit below, and then it will just find out the nearest surface point. So it will show the flow point or flow path of this droplet. So similarly, you can continue this uh, flow until you want to see the flow line in your model. Okay, so for my case, I've run 200 iterations. So it will show the flow line of the continuous flow of water on the surface. Okay, and I'm using the morph tool again to visualize this particular flow line on Archicad. And once when I sync it with Archicad, I'll be able to see the Archicad model with the flow lines on the surface of the mesh. Okay, so this is actually not a rain simulation, but it's a water flow line simulation. So you can just find out how the water will flow on a surface once it is once the rain hits the surface. Okay, so let me go back to the presentation. All right, yeah. So we have come to the end of this session. Do follow us on Instagram, Facebook, and LinkedIn to know more about our solutions and future webinars. And we also post all the webinar recordings on the YouTube. So scan the QR code and you'll be able to find out our YouTube channel, which has all the webinar recordings there. So we'll be posting the webinar recordings of this series as well soon. And you will be able to watch it. And if you need to implement these workflows on your project, you let us know. We can